programming. And it's a data flow language, and it addresses the issues we talked about yesterday about parallel process synchronization, blocking, and all that stuff. And the idea is that we have functional blocks which perform some action, right? And we form a network of actions which have inputs and generate outputs, and technically they form a Petri net. So each of those blocks triggers an action when it gets its input or inputs, performs something. Let's look inside what's going on there. A piece of Smalltalk code in this case, right? So, and it produces on the output pin a value. In this case, this one reads a file, takes the file name on the input, this one, reads an image from file, raises an error if it's not there, and produces an output value, right? And if I run it, I can take a look. I get a trace, and I can get a look what happened. I see the output pins, I see the data, I can inspect it, like that. Like that. So that's the basic idea. We have a data flow language underneath in which you formulate your processes. Now, what has it to do with testing? In testing, you write a model of your environment, of the outside world, and you test your system against the outside world. You simulate the outside world. And how do you simulate the outside world? Well, the problem is, it's not you I'm addressing, because you are all programmers, and everybody of you says, I can do this in 3 lines of Smalltalk code, right? But if I go to a banker, he doesn't know how to write Smalltalk code. But he knows I have to do this transaction, I have to enter this data in my form, I have to check the database if the record is correct, and stuff like that. So he thinks in processes which he can formulate once he has given those elementary blocks. And once he has a bunch of elementary blocks, he can go there and say, okay, I want to do something new. Let's say I want to do a new action.
Can you zoom, please?
But
we can't see anything. It's too small.
I can probably zoom a bit, or I can
change the resolution.
Change the resolution a little bit. Sorry. The problem is I can't show a lot. The resolution is too small. Is that better? You don't really need any detail, so just the concepts. If you can't read the labels, it's better? Okay. So you can create a new action, and in this new action I would like to say, okay, I want to take an image, let's say, Steph, which is this one, which I took yesterday. And I have it as an attachment in here, so I drag this over here. And this is a funny action. It's just an attachment action which produces the file name as output. I want to say, okay, take this file name and read me contents. So for something like image contents, image from file looks good. And I can run it, of course, immediately, and let's see what I got. So here is the output. Actually, here's the input, which was a file name. File name in this case, and the output is an image. What do we want to do with this image? Well, let's see what we have. Let's say, okay, let's rotate it maybe. Rotate image. And it needs an angle, so in this case, where should the angle value come from, right? I don't have a step. I can say, okay, let's use a constant. Maybe let's say 30 degrees. And run it again, and I'll see what we got. Rotate the image. Well, it might be nice if we open a little dialog which shows a little view which shows us the stuff. So let's put a new step in here which says show image. Show image in the local view. Well, if that's got, if it's getting too much, I can do something like that, or, which is also quite cute, I could say, well, let's refactor this and make this a new compound. Alright, so I can say, these two, what do they do? Refactor. extract new compound action, and it should be called get me step. Oops, that was wrong. Let's go back. Sorry. I have got the new get me step somewhere. Let's see. Where is it? Here. Get me step. Here it is, and it has the. Actually, you see the output is coming out here now. So I got a new block which on the outside looks like this, and on the inside looks like that. So you see, I can arbitrarily nest those blocks, like functions or subroutines if you like. But I don't want to do this. Actually, I want to do something else. I want to say, okay, oops, that was too much. Shit, one undo too much, and I have forgotten my reading, but I have prepared it here. Yes. So here is the, let's do it again. I refactor that and say extract and replace. So get me step. So I have this get me step here, and I have a private action which is get me step in this case. So like this. And okay, here's the show image at the end. Show image in viewer. It will open a viewer and will. Well, in this case, okay, this is already too much. The next thing I want to show is that a block can have multiple outputs, right? So it can send multiple values to this output. And these things in between here are not message sets. They are actually queues. Which queue the values which come in. And for each value which arrives here, another action is started. And actually those actions run in separate threads. So if you have multiple fires at the same time, they all run in parallel. So this solves the parallelity problem, because those banker guys, they don't want to do semaphores, critical blocks, or stuff like that. Right? Of course, you can't do it in any situation, because in some situations, for example, if you have a side effect in a block, like you update a database, then you don't want to use parallelity, and then you can put locks here as well anyway. So we have features like that as well. Now, that's the basic mechanism. Let's look into the generate service just for a second. So now this is funny because you can choose a language here. We have both Smalltalk or JavaScript and a few other languages here. So whatever you prefer, and many have a feeling that they feel more comfortable with JavaScript. So we have this kind of JavaScript here where they have their for loops and stuff like that. But what you see is that the output is written multiple times here. That's why this output here gets multiple values. You can run this here, for example, and then you see on the pin output, you see, okay, it's generated those values. Internally, every value, everything that flows in the system gets a timestamp and it's logged, and you can save the logs, you can reopen the system at any later time and look what happened and give it to the developer and say, look, at this pin, this value arrived, and then you can inject it. Now, how does this make a test system? Because now it's just a programming language, right? A nice programming language, I think, with a few new features. And you can get down to the Smalltalk level at any time, by the way. I mean, that's a full Smalltalk X system underneath. So let me just open browser. So if you like, you can go on this level, and then you see all the Smalltalk code, and I don't know, let's go to strings of below. And well, here you see all the stuff there, like whatever there is in string, right? Copy. So you can add code here as well. It will be saved to the test beat. So if you are a hardcore Smalltalk, or if you have anything which you can't do on the block level, which is highly likely if you have special hardware to connect to, or if you have something else, which is a protocol to feed or whatever, or a SOAP or HTTP server, you can go on the Smalltalk level, write your little thing, and write a little wrapper block, which just calls into that. Right? So you have, there's no limit in what you can do in the system. But the actual test designer, the one who is doing the test scenario, will usually stay on the block level and just connect the blocks which you provide to him if you are a hardcore Smalltalker. And that's the typical role in a test scenario. You have a few specialists who do the interfacing, and you have the poor guys who do the hard testing, and they just connect blocks and run the tests. Right? So you have a nice separation of roles. All right, now how does it make a test system? Well, it makes a test system by having a bunch of blocks which do what you need, right? Which interfere with your system. And we have a bunch of libraries already in there, for example, to access databases, mainframes, ADFACT, and to simulate GUI. For example, we have a library with which you can manipulate a Java GUI. And I have a little GUI browser for that as well, if I find it. Let's see. This one. That's the wrong one. That one. And I also need, what's that other thing? Oh, there's my Java. They don't have icons here. Yeah, this is a swing set, which is just a demo of all the widgets which Swing has. And we have a GUI browser with which you can enter and look into your, oh, by the way, here you see multiple technologies, so that's probably not interesting for you now, but here is the Smalltalk image itself, and I see all the GUI, all the widgets, and all the applications on top, and I can go in there, and probably that's no longer there it is. And it gets out all the possible actions which I could do with such a component once I have it. And I see the attributes here. And I can compose a little test right in this GUI browser. I can say, okay, I want to press a key, a button on this toggle. And I say, okay, that would be the block which I need, right, to do that. And so I can compose interactively. I can browse my GUI, see all the widget components, and go into the panels. That's the Smalltalk image itself. So, and the same is true for other technologies. We can bind to Java Swing, we can bind to Java SVT, we can bind to Qt technology. We have a .NET interface. We have a Selenium adapter with which you can remote control web interfaces and stuff like that. So, for example, I look at this menu item here, and I can say, okay, I want to do a button, click, and if I think that's a good thing, I can try it here, right? Try it already. You don't see, I should probably take it wrong. Click. Okay, you see clicks here. Look at this one. So whenever I run it, and I can say, okay, that's a good thing. I want to click on it, and I take I take this action and I put it in this working area, and then I can say, make me a new block. Click in the block. And then I get a new action block. Where is it? Well, let me search it somewhere here. Click in toolbar, and there is this action. Actually, this is a table representation. It's the same as the other one. We have multiple representations. Some prefer the tabular, which they call keyword driven. Some prefer this network view, but it's basically the same as long as there are signature. So that's the way how you can interactively create new. And of course, you can refactor it at any time. If you think after this block I need something else, maybe a delay, or I should wait 100 milliseconds after pressing a button before the delay comes up and stuff like that, you can always edit afterwards on this level. Now, what happens with when you can also, of course, you can also capture a session and get all the actions which you did as a sequence and take this as the basic, right? Or you can import Selenium recordings or XML recordings in our formats to get those networks. Yeah, basically that's it. I mean, I can talk about all the technologies and all the adapters we have. That's probably not very interesting. I can show you a few more things about these parallel stuff. Let me open let me show you the self-test itself. We have a self-test by which well, that's probably something which you can follow. So here is something to test the workspace, a Smalltalk workspace, or Smalltalk self-test. What we want to do, we want to start the workspace application, we want to edit some text, enter some text, we want to click on do it, and we want to finish it afterwards. Now, how does it look? Well, starting the workspace application is here. We have a block open application by class name, and if I look into it, it's a little bit ugly, but basically what does it do? well, it's an open application. And let's go back. And then I remember here I get an application handler, and I remember in an environment, we also have environments, every block can have a local variables which are defined here. By the way, the connections are typed, so we have a type system underneath, so you can protect the test developer from making wrong connections, right? Connecting a number to a pin which expects a finite, for example. And okay, and here we want to move. Let's run this. Okay, so it opens our workspace, regular workspace. So next step would be, what is any text? Well, we want to say, that's one thing. You can get to the name of a widget or an application by XPath. So we use XPath everywhere to access objects, to accept message paths, object paths, and to address widgets. So that's a general mechanism we use everywhere. And whenever you do a recording, it doesn't guess on a good XPath. The guess is just all the components, which is usually too long, right? XPath, you can say / and then leave out components. So that's why you see all those long names here. But you can, of course, edit it and say, I don't care what it is. It's something which has, I have to say, anything which has a window title like test app, and then I want to see the test view. This might be problematic if there are multiple instances in the system. Okay, so what does it do? It says, hello world, this is the input, and it sets the text, and then, oops, always have a problem with Mac, thinking that it goes to right, I should be able to resize it. Oops. And yeah, that's it. So let's set the text, then it does some default input, gets the text, and then it verifies if the text is correct. So I did some default input and added a here, and I assert that it's equal. Let's run it. And now I get a bug, a mistake, because I closed the window, and this test case actually expects that the window is there, right? Because remember, I did the start with the application and I closed the workspace. So that's it. There you see how I get error reporting. Now, test development is also development. Test development is programming. So you need a debugger and you need all that single stepping and every feature you usually expect from a development system you also want to have in a test system, right? So what can we do here? Well, we can do, for example, breakpoints. We can put a breakpoint on a step. And I can put, if I want to look inside, let's go to this one. I can put a breakpoint here as well. Let's run it now. So first of all, I want to open it. Let's go back. First of all, I want to open it. Right, here it is. And then I want to do the edit text. Right. And here we are at the breakpoint, and it tells me I am here at this point, at breakpoint. And you can put what the input was, and then you can single step through the network, or you can proceed. And this is the second breakpoint, and here you see the Smalltalk debugger. Cool, right? And you can actually, of course, edit here, accept, proceed, restart. All the typical Smalltalk features are available here in this system. So the Smalltalk guy has all the Smalltalk world, and the tester guy has all these high-level abstract model-based, or whatever you want to call it, features. Another bug, and what is also interesting, you see here the trace of all the things, all the actions I did with the time, how long did it run, milliseconds, every input, every output, every value. So, what kind of plugins do we have? I can show you an overview. Plugins. Quite a bunch of stuff you can import from Quality Center, SAP, interfacing. Windows automation, we have interfaces for phones, mobile phones, iPhone, and end-to-end test, for example. You want to test some application where you have a mobile phone, you enter something, you want to look at the web UI, whether you see the transaction, and you want to, at the end, go look at the database and see if the transaction was right, because your web server can cheat, and everything comes out of cache and never went to the database, things like that, right? So we have SAP connection, web test stuff. We have test imports. Usually people write their tests in Microsoft Word or Excel requirement sheets and can import them, and we get automatically, you get those step lists and generates those stuff. We have interface to Jira and other things. We can generate test reports. That's probably an interesting thing. Once you have these individual steps, you create what we call a test plan, which is just a sequence of individual test cases, and then you can run the complete plan, which is this one. Probably should be a great point. So, get rid of that. Should probably get rid of this one as well. And so now we have run a test, and by purpose it has some error in it, but let me now create a report on that, so you get a nice PDF report. Actually, you can choose last execution of that thing. And I want to have PDF, but you can also have JUnit compatible reports, so you can send it right to Jenkins, and Jenkins can produce all the fancy stuff for the history and traces and stuff. And when you generate a report, it takes a while because, and there it is. So here is all the individual, and actually the detail can be configured. You can say what you want to see, to which level down, or the pin data, or only the pie chart or stuff like that. So I'm all done. I have 5 more minutes for questions. All then. Yes, Megan.
You use this to communicate with, in part, to communicate with your customers, is that right?
No, I sell it to customers so they can write their tests.
Ah, right. So the customers actually write the test in this. So you mentioned that some of the customers were actually happy with JavaScript. Would I be right in assuming that those were the customers with some programming experience, and that the customers with very little programming experience actually prefer Smalltalk?
Well, when you do a test, the customers usually have complicated technical equipment. So customers, let me just give you the background. The customers are from, for example, Airbus is a customer of us, right? And they have complicated equipment in their airplanes, or with Bosch, which does all the car control stuff, like Daimler and those guys are. And they usually have to connect to their equipment somehow. Some do it via Java or by calling functions and stuff like that. And for that, they need to have initially a bunch of the elementary building blocks which connect to their systems, right? As a base on top of which they define their sequences. And to this, they have to program it somehow. And if I say, oh, you have to do it in Smalltalk, they say, I don't know Smalltalk. I'm sorry, that's Flutter. So we wrote this little JavaScript integrator which generates Smalltalk bytecodes, and then the argument is done. We say, okay, get a book on JavaScript, and you understand how to write it. Now, of course, it's cheating from my side, because the object model underneath and the classes and everything is Smalltalk, right? So they have to learn this as well and use the browser to find their way through all the documentation. But at least the initial argument is gone, right? Okay. Next question. There was another one over there. So everybody's happy.